Hello, this is Mrs. Reed, and this is Lesson 5.7a, Systems of Inequalities. Our essential question for today, how can I solve systems of inequalities? So what are the steps to solve a system of inequalities? Step 1 is we solve the inequalities for y. Next, we graph both inequalities on the same graph, and we shade a different way or use a different color to show that. Step 3 is shade the overlapping area a darker color to distinguish the solution. Step 4, check a point in the solution to verify the answer, or a test point. Looking at example A, I see that I'm given two inequalities to graph. So we're just taking what we've done in the previous lessons, but instead of only graphing one inequality on this graph, we're going to just graph two on there. And then where they overlap is going to be the solution area. So I'm going to start by graphing the first inequality. Y is less than 2x plus 3, and I'm going to do this in red. So the plus 3 tells me I'm going to go up 3 from the origin. So here I go up 1, 2, 3. Next, our slope is 2, because that is what is with the x value. And our slope is 2 over 1. It's positive. So from my point that I just made, I'm going to go up 2 and then over 1. And I'm going to do it again, up 2 over 1. And I can continue to extend my inequality line here downward by going down 2 over 1. Down 2 over 1. So go ahead and do this with me, please. Down 2 over 1. Down 2 over 1. Down 2 over 1. And remember that less than is dashed. So make it be a dashed line. Next, I need to check a point to see where to shade. I like to test 0, 0. So I'm going to check this point right here, just because it's easy. And instead of y, I'm going to put a 0, less than 2 times 0 plus 3. So 0 is less than 2 times 0 is 0, plus 3 is 3. Now I have to think, is 0 less than 3? Yes, it is, so I need to include it. So that means when I shade, I want to include the area below the line. So this part down here. So go ahead and shade that part. Go ahead and take a minute and try to graph this second inequality on the graph. Remember that the y-intercept is 5 and the slope is negative 2/3. So go ahead and graph that one, please, and then you'll check it with mine. So the first thing you should have done is place the y-intercept on the graph. So I did that by going up 5 from 0, 0 and putting a point. Next, you should have graphed the slope on there. So from the y-intercept, we go down 2 over 3, down 2 over 3, down 2 over 3, or I can go up 2 over 3. This inequality is less than or equal to, so it is solid. Next, I need to check a point. I'm again going to check 0, 0 because it is not on the line, so it is one that I'll be able to check. I plug 0 in for y, less than or equal to negative 2/3 times 0 in for x, plus 5. So then I get 0 is less than or equal to negative 2/3 times 0 is just 0, plus 5, I'm left with 5. 0 is less than or equal to 5. It's less than, so that's true. So it is a part of the solution area. So when I shade, I want to include the point 0, 0. 0, 0 is right here, so I want to include that side. So I would shade like this. And now our solution area is this area here that has both blue and red. And if you use highlighters, they actually change color, so that's kind of fun. So then this whole area right here is where all of the solutions are. If you take any of these points and you plug it into either of these inequalities, we'll get a statement that is true. So now we need to check, are the following solutions? So we're going to graph all 4 of these points and determine if they are solutions or not. So if they fall in this yellow area here, or on this blue line touching the yellow, they will be a solution. That's the only areas that will work. So let's go ahead and check the point 3, 1. So from 0, I go over 1, 2, 3, and then up 1. So we'll just put a point right there. So that is the point 3, 1. We went over 3, up 1. It is in the yellow area, so yes, 3, 1 is in the solution area. Next, we need to check the point -1, 1. Start at 0. -1 tells us we go left 1. Then +1 tells us we go up 1. So let's put a point right here. And that is the point -1, 1, which if we look, it is on a dashed line. So this is not part of the solution. It's because it's on a dashed line. A dashed line is not part of the solution because it doesn't equal it. It would have to equal it for it to be part of the solution. Next, let's check 3, 4. So we go over 1, 2, 3, up 1, 2, 3, 4, and put a point right there. So that is the point 3, 4, which if we look, it is in the red area. It needs to be in both red and blue, so both. So this is no. And let's actually go ahead and put X's on the ones that didn't work, just so we can see quickly. Next we have the point -2, 4. So we're going to go left 1, 2, up 1, 2, 3, 4, and we're going to put a point right there. Alright, so looking, the point -2, 4 is in just the blue area, so that is not a solution to both of the inequalities, so no. It needs to be in the area where they both overlap. Example B, you try. Solve the system of inequalities. So what we're going to do is, I'm going to have you try this one by yourself, but we'll check it one inequality at a time. So take a moment and go ahead and graph this inequality on the graph to the right, please. And then we'll check and see if you got the same thing that I did, and then we'll do the second inequality. So go ahead and do that first inequality on the graph, please. Alright, so if you graph this line correctly, it should be starting at 1, go up 1 over 2, up 1 over 2, or down 1 over 2. It should be a solid line because it is equal to. And next we need to check a point to see where the solution area is. We can check any point we want that is not on the line, and since 0, 0 is not on this line, I'd like to check that point because it's easy. So 0 is greater than or equal to 1/2 times 0 plus 1. So 0 is greater than or equal to 1/2 times 0 is 0 plus 1. I'm left with 1. 0 is bigger than 1. That's not true. 0 is equal to 1. That's not true. So this is no. So then when I shade, I don't want to include that part right there. So that means we shade this top part. Take a couple minutes and go ahead and graph the second inequality, please. So if you graph this line correctly, starting at 0, I'd go down 1, 2, 3. That's where my y-intercept is. Then I would go down 1, 2, 3, 4 over 1. Or I could go up 1, 2, 3, 4 over 1. Because 0, 0 is not on the line, I can check it, so I'm going to use that. 0 is less than or equal to -4 times 0 minus 3. So 0 is less than or equal to -4 times 0 is 0, minus 3, I'm left with -3. 0 is less than -3. That's not true. 0 is equal to 3. That's not true. So this is saying that -3 is bigger than 0, which isn't true. So I do not want to shade over here. So that means I want this side of the line. So then the area where I have the two colors is my solution area. So I'm going to make that darker or a different color or shade a different direction. And again, if you use actual highlighters, they change colors. So that would be my recommendation because it's more fun. Take a moment to graph those 4 points, please, on the grid, and then determine whether they are solutions or not, please. Alright, so the point 4, 1, 4, so we go right 4, 1, 2, 3, 4, up 1. That is not in the yellow area, so no, that is not a solution. Negative 3, 2, I would go left 1, 2, 3, up 1, 2. That point right there is in the overlapped area from both inequalities, so yes, that one is part of the solution. Next, negative 1, 5, so we go left 1, up 5. That is in the red shaded area, not the overlapped area, so no, that one is not in the solution. And last, we have negative 6, negative 2. So negative 6, negative 2 would be left 6, down 2. This one's tricky. It looks like it's in the yellow area, the overlapped area, but really it's on this line right here. And I look, it's on a solid line. That's good. And it's touching the overlapped area. So yes, this point is included in the solution area. Example C, solve this system of inequalities. So for this one, I have 2x minus 3y is less than 12. It would be a whole lot easier to graph this if I had the y by itself. So we're going to go ahead and manipulate this a little bit and get y by itself. So we're just going to solve the inequality for y. So I draw my line down, and I want to get rid of this 2x. So I have subtract 2x on both sides. That leaves me with negative 3y, and the inequality sign does not change from subtracting, so less than 12 minus 2x. Now this is negative 3 times y, so I'm going to divide by negative 3 on both sides, which if you remember, that actually flips our sign. So now it says greater than. 12 divided by negative 3 is negative 4. And negative 2 divided by negative 3 would be positive. Let's keep it as a fraction. 2/3 x. Take a moment and go ahead and graph that inequality, please. Y is greater than negative 4 plus 2/3 x. So you should have put your y-intercept down at negative 4. You start at 0, go down 1, 2, 3, 4. And then the slope is positive 2/3, so up 2 over 3, up 2 over 3, up 2 over 3, or down 2 over 3. Now you need to determine if this should be a dashed line or a solid line. So you look at this sign right here, it says greater than, so that is a dashed line because it does not have the equal to. So go ahead and make it dashed if you haven't already. Then we check a point to see where to shade. So my equation, or my inequality is y is greater than negative 4 plus 2/3 x. So 0 is greater than negative 4 plus 2/3 times 0. So 0 is greater than negative 4, and 2/3 times 0 is just 0. 0 is bigger than negative 4, so I want to include 0, 0 when I shade. That's right there, so we do that whole side. Now we need to solve our second inequality for y. So we draw the line down, subtract 10x from both sides, trying to get y by itself, so I have 5y. Subtracting 10x doesn't change my sign, so it stays less than or equal to 20 minus 10x. Divide by 5 on both sides. So y dividing by a positive 5 does not change my sign. 20 divided by 5 is 4. Negative 10 divided by 5 is negative 2 with the x. Take a moment and graph that inequality. Remember to determine if it is solid or dashed, and go ahead and figure out where you should shade also. Alright, so your line should look like mine, and now I'm checking the point to see where to shade. I like to check 0, 0. So I have 0 is less than or equal to 4 minus 2 times 0. So 0 is less than or equal to 4. And now negative 2 times 0 is just 0. And 0 is less than 4. So that is good. So when I shade, I want to include the point 0, 0. 0, 0 is right here. So I shade everything on this side of my line. So now you should be able to see where the overlapped area is. So make it darker or make it a different color or something so that you can see where the overlapped area is very well. Alright, and there you go. So hopefully you should be able to solve systems of inequalities by yourself now. And this concludes lesson 5.7a.